Hey guys, today's lesson we're going to be talking about primes. Let me just do a very quick recap on prime numbers. So prime numbers are what we call numbers with only two factors, 1 and itself. Okay? So for example, if we have the number 13, the only way we can get to number 13 is by timing 1 times 13. Do you see? 1 and itself. Okay? And on the opposite side, we have what's called composite. So composite numbers have more than two factors. Okay, so let's look at number 6, for example. So for example, we have 6, and we can build a little t-chart for this. Remember, we can always multiply 1 in itself to get 6. And then another way we can get to 6 is also 3 times 2. Okay, so because this one, 6, actually has 4 factors, it is no longer a prime, it is called a composite. So again, prime numbers has only 2 factors, 1 in itself, and composite numbers can have more than 2 factors. Now, the next thing that we will need is, in order to find primes, is what's called a divisibility rules. Okay, and this is how you spell it, divisibility rules. You can actually find these charts online. Just use a Google image and you'll be able to find divisibility rules. You can make a print out, and this is a great resource for you to have at all times in your math notebooks. Okay, you can actually use this for upper grade level, so it will never go to waste. The list may look like it's a long list when you Google it, but I'm going to show you a way where you can actually just remember it very quickly. So the divisibility rules, if you don't know what it is, actually we talked about this in class, but if you don't know what it is, the root word is divisible. That means it has to do with something dividing. So some of the rules for a number, to see if a number is divisible by 2, is that if it ends in 0, 2, 4, 6, and 8. Did you notice in my 2's facts family, it ends in 4, 6, 8, 0, 2, 4, 6, 8, 0. These are all what we call even numbers. Okay? And here's the tip right here. Any number that is divisible by 2, it is most likely, not always, but most likely will be also divisible by 4, 6, 8, and 10. Now, in order for us to see if a number is divisible by 3, we have to add the digits together. So what we need to do is we add the digits, and I'm going to show you in a little bit how that works. And then after you've gotten the sum of the digit, you're going to divide it by 3, and if it divides evenly into 3, then that number is divisible by 3. And any number that's divisible by 3 will most likely also be divisible by 9. Now, another rule that is good and easy to remember is for 5s. Notice how my 5s right here, all of the digits, all of my facts end with either 0 and 5. Okay? So any number that ends with 0 or 5 is divisible by 5. And 10 is also kind of the same thing. 10s, notice the ending numbers all ends with 0. Okay? So with this said, when we're looking for primes, the only thing that you will actually have to divide are to test are numbers 7, 11, and 13. Okay, so now let's go ahead and see how we can apply this into how we can find prime numbers. So as you can see, I have a divisibility rules right here, and I also have my multiplication chart to help me. So for example, for today's example, we're going to work with numbers 30, 23, and 93, and to see which ones of these are prime or composite. Okay, so we're looking for primes and composite. Now let's look at 30. A smart student would actually use the divisibility rules first. Okay, so the one thing that I noticed about 30 is that it ends with a 0. That means it's divisible by 2, 5, and 10. You know what? The minute it's divisible by any other number but 1, it is already a composite. So it is out of our list. It's composite. Okay? Now let's look at 23. 23, I look at the ending and I see that it doesn't end in an even number, so I know it's not divisible by 2, 4, 6, 8, or 10. Notice how many numbers we've just eliminated just by looking at that ending. Okay? Then we're going to check to see if this number is divisible by 3, and how we do that is we're going to add the two digits together. When you add these two digits, you're going to get 5, and we're going to ask ourselves, is 5 divisible by 3? And we don't see 5 in the 3's facts family, so we're going to say no. Because of that, this number is not going to be divisible by 9 as well. Okay? Again, we look at the ending again, and we don't see that it ends with a 0, so we know it's not divisible by 5 nor 10. Now, let's see if it's actually divisible by 7, and we have to actually divide. So let's see if 23 is in here. Nope, it's not. So it's not divisible by 7. Is it divisible by 11? 23 is not in here. Nope. Now, if I extend my chart to 13, my next fact in 13 will be 26, because 13 times 2 will give me 26. Okay? Again, 23 is not in the 13's facts family. So I know that 23 is prime. Now, I'm going to pause right here, and I'm going to show you how to actually use the multiplication chart in this case, because this is such a small number, like 23 is a small number. I'm going to show you how to actually quickly use the multiplication chart to find that 23 is prime. Here's how. Notice how I ran a line right across here and down here. What I'm trying to do is I'm trying to separate counting numbers. So all of this in the gray shaded area just means that I'm actually these are just my counting numbers. These are the facts family of 2, of 1s, 2s, 3, 4, 5, 6, and so on. Okay? Now, anything that's in this area right here must be, in order for them to be present in this area, they must be a multiple of two different numbers. For example, 4 is a multiple between, okay, so 1 and 4, and also 2 and 2. That tells me that 4 is composite. Anytime when you see a number in this area right here, they are all composite. Okay? If you don't believe me, take one of these numbers out and see if that makes sense. Remember what I told you. Composite numbers are numbers with more than 2 factors, right? So let's try 54. Let's go ahead and create a t-chart for it. We know that 1 times 54 are 2 factors. We also know, because it's here, that you can also have factors of 6 times 9. And the minute we can prove that this 54 is divisible by another number but 1 other than 1, it's already a composite number. We don't have to do anything else. Okay? In this case, let's try to see if we can find 23. Let me go ahead and erase to see if we can find 23. Okay? Let's see. I see 20, no 23, no 23, no 23, so on and so forth. No 23. You will not see 23 anywhere in here. So therefore, you can confirm with very strong conviction that this number is a prime number. Now, let's look at 93. Okay? 93 is the one that I would use divisibility rules for, just because it is a bigger number. It's one of those bigger numbers. Okay? So I look at the ending again, and it doesn't end in a 0, 2, 4, 6, or 8. So I know it's not divisible by 2. Let's see if it's divisible by 3. Okay? If I add these two digits together, what do I get? I get 12. 12 divided by 3. Let's see, we're in the 3's family. Let's see if 12 is in the 3's family. And 12 is one of the facts in the 3's family. So I know that this number is actually divisible by 3. So this tells me that this is a composite number. Now, the reason why I have to show you the multiplication table, and also I have to show you the divisibility rules, is because 93 is actually on here. The only problem with our multiplication table is that it ends at 12s. So, in order for us to figure out what the multiples are for 93, we can also divide. So let me go ahead and move this down, okay, to show you the division problem for 93. Okay, so I'm going to divide. So 9 divided by 3, okay, we're going to put our finger on the 3's column, and 9 is right here, so we know that 3 times 3 gives us 9. 3 times 3 is 9. We subtract it, we get 0. And now we bring down this 3, and 3 divided by 3 is 1. So we actually, 93 actually has at least 1 times 93, but it also has 3 times 31. Again, like I said, the only reason why we can't find it on our chart is because 31 is too big. We don't have up to 31 on our chart. Okay, so that is it, guys. This is how you can use just these rules to find primes. Remember, primes are numbers that only have 2 factors, 1 and itself. And in order to find primes successfully, you will need to use divisibility rules again. Okay, you will need to use divisibility rules, and you will also, another helpful tool for you would also be a multiplication chart. So have fun and good luck with all your problems.